just to return to the first part, whenever we shift up or down, what we're doing is we're changing what we call the sinusoidal axis. And that's the axis about which these oscillate. So over here, for this one, our sinusoidal axis is -1. So our sinusoidal axis here is y equals -1. And our sinusoidal axis here is y is equal to 2. Okay, moving on, amplitude. Suppose that a circle with radius 2 is placed with its center at the origin. So now it's not a unit circle. It's a circle of radius 2. And we're looking for the coordinates of the point. Well, when theta is equal to 0, our coordinates are going to be 2, 0. When theta is equal to 30 degrees, though, we're going to have something that looks like this, right? We're going to have 30-degree angle. This is still 2. So the side opposite 30 degrees is 1, and the longer one is √3. So our coordinates are √3 and 1. When theta is 90 degrees, we're going to be, again, we're still 2 units from the origin, so that's going to be 0, 2. And at 180 degrees, our coordinates are going to be -2, 0, right? Because we're 2 units over here. And at 225, it's a little bit harder, but we know our hypotenuse is still 2. So if we divide by square root of 2, right, our coordinates are going to be negative square root of 2 and negative square root of 2. So let's look at just our x values. When theta is equal to 0, our x value is 2. At 30 degrees, well, let's just skip to 90 degrees. Our x value is 0. At 180 degrees, our x value is -2. Then we're going to be back at 0 again. By the time we get back to the beginning, we're going to be back up to 2. So this differs only in that what we would say is the amplitude, the distance from the sinusoidal axis to the highest point. In this case, our amplitude is equal to 2. And if we look at what's going on with the y value, well, it's the same situation. At 0, our y value is 0, but at pi over 2, our y is up to 2. Then 0 at 3 pi over 2, our y is -2 and 0 again. So once again, this is just like the normal sine curve, right? Normal sine curve, which goes between 1 and -1, except that this is stretched. So let's see, if we were going to graph -2 sine theta, not only is it going to be stretched, but it's going to be reflected over the x-axis. So this is going to start at 0, but instead of going up to 2, it's going to go down to -2. So this is a stretch and a reflection. And even though this is going down, we're still going to say the amplitude is 2, because the amplitude is just a distance.